Designing for variable amounts of data with digital signage. Getting creative when you have viewport constraints. So this is just a presentation from Nottingham College about how we use our digital signage, but also how we have to deal with dynamic data and the different sorts of screens that we have deployed. And it's kind of a bit of a sort of an explore into what we've sort of looked at and what we do and kind of the concepts behind it. Dynamic data challenges. So dynamic data is great for digital signage, but it presents a few challenges, particularly when we're talking about fixed screen sizes. So it's essentially you can't really go outside of the confines of the area that you know that the screen's at. So let's say 1920 by 1080, typical standard full HD resolution at 16 by 9 aspect ratio. That screen area is only going to be that size. It can't be any bigger and it can't be any smaller. So that's what we've got to work in. And that's where dynamic data potentially can create a bit of a challenge. And that's not always going to fit in that kind of screen area. So depending on what the data source is or what the API gives you, it could be variable. So there's got to be some extra handling on how we do that. So one of the areas that we could sort of have problems with is text content. So variable text content is often tricky because you sometimes might not know how much you're going to get back, or you may get varying levels of it back for one item and then more on the other. And this can potentially be a bit of a nightmare for some layouts, so you could get some height differences, potential text overflows, or even perhaps collisions with other elements depending on how they're positioned. And of course, it may exceed a boundary, so again, overflows and ultimately doesn't look great. So the general amount of data that you receive as well may typically cause problems. So it might not be known for a start. So you may get a variable amount back on a regular basis. It might change every sort of, ranging from a couple of minutes to 10 minutes, an hour. You could get a variable amount of data back. And that's tricky sometimes because you can't necessarily design around a infinite amount of content. So these sort of challenges basically mean that we have to be mindful of the challenge, but we also don't want to compromise the principle of digital signage either. Obviously, by not reducing the amount of information necessarily, but being able to adapt to the problem. So there's initial solutions and workarounds. Some are better than others, but these are sort of like starting points. So variable text, the easiest one there is truncation. So you can set a max character limit or word count, because sometimes character limits truncating on pure fixed characters could easily split a word and look a bit bad. Whereas you can do it on words as well, which is better. There also are fancier truncation methods which take into account words as well, so it won't necessarily split on certain words as well. So there are smarter truncation options, but essentially truncation is a way to guarantee that you will only get a maximum amount of text by truncating it to a certain value. And you can also do the ellipses trick where you basically just put 3 dots at the end after truncation, so it kind of visually communicates that there is more content, or there should be more content, but it's been cut because of the length. So talking about items of data coming through, I mean, of course, you can set a fixed limit, a fixed value. So if you have potentially could get up to 20 items, you could set a cap of 10. You could do that. This then allows you to build around that value because you've basically capped it, which is fair enough. Also, the other sort of side to it is ordering of the priority data. So in an API, there may be lots of data in APIs that may be useful or not, and prioritizing the data is important. So typically using like news content as an example, this data is typically going to be beneficial by being ordered on, say, the published date, i.e. being the most recent, so in descending order. Or on a last updated date, i.e. the frequency of the information changing. So this at least means that you're prioritizing the most key data. If you've got a list of, say, 10 items, you're prioritizing those 10 items in the order that makes the most sense. And of course, filtering data as well. So again, APIs providing a lot of data. You can, of course, filter data. Sometimes APIs let you filter through directly through the API, or you can do your own filtering, say with manipulation of arrays or anything like that. But that allows you to almost sort of select real fine grain the data that you're interested in or want to communicate or display. So a few of those kind of almost give us sort of some solutions, but they really don't address the problem of variable amounts of data itself. So we've talked about setting fixed limits, and we've talked about obviously like doing smart things to do that. But let's say, for example, we've got an API that could be returning an average of 30, 40, 50, 100 items. Could be anything. We don't know. And setting a cap is going to potentially lose out on some of that data that's quite important. So we can't set a fixed limit. So what can we do? Now, the simple solution, or one of the most basic concepts, is pagination. But it actually comes in really quite useful for digital signage because the key constraint is that we only have a certain amount of space, and that will always be true no matter what. While web deals with different device sizes, signage is pretty fixed, but what you've got is what you've got, and there's no real movement around that. So pagination and fixed limits kind of solve each other's problems. So fixed limits provides consistency, but it's too restrictive in the sense of you may cut out content that you want, but you're cutting the content because you can't fit it. However, pagination allows you to potentially batch or split content by per page basis or per batch basis using a fixed amount. So rather than fixing the amount overall of items of data coming through, we're saying, okay, there's potentially 50 items coming through, but I want to display all of those items still. I'm going to batch that by 10 per page. So that gives me 50 items still, so I haven't lost any of those items, but I've now got 5 pages of data. And obviously, while pagination is used for performance reasons, obviously on websites and basically splitting like large data, we can really leverage it here because the fixed limit problem is purely on a displaying an all at once basis. So with pages, we no longer have the problem of having to display or potentially trying to fit all of those items in one space. We can potentially have multiple spaces that we then can display as and when. And by using pagination and modern web sort of techniques with layout grids, this then starts to allow us to build more flexible layouts to handle large amounts of basically data and content without actually restricting us. So where might data pagination be beneficial? So one of the examples I can give is the BBC News RSS feeds. Now RSS itself is quite an old school, format. It's kind of almost had a reinsurgence, to be fair. It had its thing, then it died a while, and then it's kind of come back a bit. I mean, at the end of the day, RSS is just essentially a dialect of XML. And I'm not going to lie to you, I'm not a fan of XML as a format. I think there's much better formats today, but XML is still commonplace and prevalent. Now, the BBC RSS feeds, they have many, but we'll just use like the front page or the main news one as an example. Generally updates every 15 minutes, and the amount of items in it can vary. Typically, it hovers at around sort of mostly around the 40 mark, depending on what the content is. But that will change probably quite regularly. Now, it's not necessarily changing every 15 minutes, but it could be changing at least sort of every 30 an hour or so. So we don't know how many items total that we were going to get from the BBC. And this is where pagination will benefit because we can then split that by X amount of pages that we deem appropriate. Another example, so upcoming events in Nottingham. So the city hosts literally thousands of events throughout the year. And of course, we can use filtering to make sure that we're only displaying relevant events. So for example, we can use the current month as a dynamic parameter to essentially only display events in that month, because obviously having events sort of way in advance is probably not that beneficial, although great for future future calendars, but not necessarily maybe in the moment. And we can do that obviously with dynamic parameters and using a sort of a driven from a date value. But again, there's a lot of events there. So typically the monthly event count is in the hundreds when it's at the beginning of the month. It does tend to obviously get lower as we get to the end of the month before the next next cycle, obviously for the next month. But that's about 100 items or so. So that's a lot of information. And then another one, travel updates and alerts. Now this one has pretty much variable factors because it could all be dependent on a lot of external factors. So forgetting technology for a second, you've got traffic, roadworks, weather, all of those factors already spell potential unknowns of how many things are going to be happening in one day that potentially are provided in an API. So that's a rapidly changing and very variable situation, and that's where again pagination and batching can be really useful. So pagination in digital signage. So applying the concept to digital signage. So the typical scenario is that a lot of digital signage is non-interactive. There are of course interactive signage, but in a lot of cases it's non-interactive. So all of the usual user actions and gestures like button clicks, taps, gestures, scrolling, all of those interaction patterns are out the window because that will be the typical user experience on, say, using a phone or a laptop or whatever, but none of those apply with digital signage. So this means that the digital signage layout itself essentially needs to perform the user interaction that would probably be normally there. And that's an interesting concept because essentially the digital signage layout has to almost be somewhat self-aware. And it's an interesting question. How can we do that? And the answer is you can leverage pretty much web-based technologies to do it. So the great thing about the web today is that we've got HTML5 and CSS3 and modern JavaScript. And then, combining it with something like Twig, which is a templating front end, you can have the flexibility of kind of building these layouts, and then also with Twig using sort of server-side-esque data manipulation. So you can obviously do template logic and more sort of complex calculation stuff, which you could do with the front end language like JavaScript, but JavaScript at some point kind of runs out of being easy to maintain when you do stuff like that. So Twig is really useful to kind of help do that, and it's kind of almost like a bit of the back end server side type end that often the front end side will not be able to do well. And combine all of those together, we essentially have the structure, style, and we can animate the content accordingly, and we can start to build that kind of interaction on an automated basis. So the typical pattern that we've gone for is a carousel. Now, carousels generally are designed to rotate through content at defined intervals. You can have either a fixed interval across all or potentially vary it depending on factors. And that allows us to have that automated cycle action without any user interaction. So how we use pagination. So at Nottingham College, we have a fair few layouts that basically leverage pagination because we pull in data from sources we have absolutely zero control of. So we've got no way of making the API provide something in a certain way. While we can obviously manipulate the content that we receive, and there's a general schema available for the API, so we know what we're data modeling around. The data returned is constantly changing and very frequently. So there's not a lot we can do about the overall data coming through, which means we have to work with what we've got. So it also means that we design around the principle of receiving data of essentially of an unknown amount, but have a typical idea of what the optimal amount per page for content of a carousel would be. So we therefore need to build dynamic layouts with loops and the batching of items per page that will fit for the scenario that we're building it for. So let's take an example. So we receive sort of 40 items from an API, so an array of 40 items. So we perform a batch on those items, and we say that 10 is the optimal amount that we can use on a page. So we've now got a maximum of 10 items to be displayed at any time, but we've got 4 pages worth of content to essentially display. So we've got 10 items, 4 pages, 40 items, and then they're going to be shown on a set interval. So one of the things that's kind of in the web world is auto playing content is actually an accessibility issue. Like normally you wouldn't advocate for doing autoplay content because it's usually going to put you in a bit of hot water with the web content accessibility guidelines. However, because this is digital signage, we can leverage autoplay to essentially create the automatic cycle of carousel items to basically or automatically cycle through those 4 pages without any interaction whatsoever. So no one has to do anything, no one has to click anything, automatic. So examples of pagination in digital signage. So here we've got the It's in Nottingham events layout, basically called What's On in Nottingham, but the company behind it called It's in Nottingham. This is from an open API that serves their mobile app. And we determined that the most optimal sort of display of items is 2 rows of 5 in per column. So that gives us 10. And you can see from obviously the page count in the top right of the video that there are a total of 11 pages, which is 10 per page, which obviously then creates a cycle of all of these event cards to go through. We're not doing anything too crazy other than we are modeling this data in a bit of a different way than we get it, because the event data by default displays the same event title multiple times. We've collapsed that, and you can see the little calendar icon on the calendar icons below some of the events. They're events that have got multiple dates but would have the same event title. We've collapsed those, otherwise we'd have a lot of duplicate events to be displayed and it wouldn't really make sense from a user perspective. So another example of pagination is the BBC News front page app that we built. So we're using these RSS feeds, we mentioned them earlier. We're doing a bit of manipulation to stop duplicate stories coming through because the RSS feed has some interesting behavior where an update to a story actually creates a new entry sometimes, so it kind of creates a duplicate. We also cheekily removed the download the BBC app call out that they stick in their RSS feeds. I mean, they're entitled to, but we stripped it out. As an extra bonus, we added in a news ticker at the top of the app there that basically cycles through the top 5 news stories that is currently on page 1. So no matter where you are in the page cycle, you will always see the top 5 stories on that ticker, no problem. So that's just another example. And the final example of pagination is Nottingham City Transport. So they're one of the Nottingham bus services in the city. And their mobile app also has an open data API, which allows us to directly get access to their service/travel descriptions. The NCT app is really interesting because it communicates 2 types of sort of disruption. One is to do with buses affected, so routes. So you can see the little squares with the colours. That's the different bus routes. And then the other one is stops. So certain stops can get closed or be not in service or due to roadworks. And this is an example of sort of variable data again, because the amount of buses being displayed for the affected routes on the cards there can vary quite significantly. And also the text as well can vary, as you can see. There is truncation enabled because it can go longer than some of these. In terms of actually the ones that are displaying currently in the example, these have all been nicely summarized, so they're not actually being truncated, but some will get truncated because they can go longer, and we've seen it before. But again, just another example of pagination, but also with the variable data side. So from those examples, they all followed the same UX pattern essentially. And that is that they needed to convey that there is multiple pages of information. So we did that for a couple of ways. So we designed the component that essentially has the current page and then the total of pages being cycled through overall. So you're displaying what the current page that they're currently that's being shown, and then how many pages actually are going to be displayed. To help further convey this, we use a little arrow icon, which you probably noticed on the videos, that essentially is a further reference or an indication that more pages are coming. However, we hide it on the last page because at that point the cycle is technically completed. With the carousel setup that we're using, it will loop back to the beginning and just keep repeating until the layout duration is reached. But kind of took inspiration from a very old sort of method of communicating information called teletext. Some people probably won't even know what that is if they're too young now. But teletext was essentially it had the same problem, particularly with TV displays, that you could only fit a certain amount of text on the screen with a certain aspect ratio. So there would usually be some form of indication or arrow or icon to say that you needed to use your TV remote to press down to see more. And this was a similar concept. Of course, they're not interacting with anything now, obviously, with digital signage method. But again, the arrow concept is very similar. And obviously, teletext had been around for a long time. So sometimes it shows that some of the user sort of patterns aren't necessarily entirely old school and still have use. And yeah, just showing some of the example of the UX. So when we've got more pages, we have the arrow icon on the right, and then when we get to the final page, that arrow icon disappears to denote that obviously there's no more pages left. Obviously, we also have the number as well, but just gives that extra sort of indication. So this is an interesting one. So we've talked about pagination and batching, and obviously how that can help with creating digital signage layouts. But there's one problem with batching, and that's maths. So batching only works. Well, it doesn't. It only doesn't just work when it's like this. But ideally, it works when you've got a equal amount of numbers to batch, and it will always be that number. And that's sometimes the case, and sometimes it's not. And because we're talking about variable data, sometimes it's not. So basically, maths is batching's worst enemy. And let's say you can fit 10 items per page in a 2 by 5 row grid. So actually, I'm describing the what's on in Nottingham layout that I've just shown earlier, and we're outputting that on a 1920 by 1080 screen, 16 by 9 aspect ratio. So the total items are 102. So we've batched it by 10, so that means we're going to get 10 pages of 10, so that's 100. But then we're going to have 2 left over on the final page, so we're going to have an uneven number on the final page because it's obviously not divisible by the batch size that we've provided. So we get that unequal amount relative to the other pages. Now that's not terrible because that will inevitably happen at some point. So it's not the end of the world. I mean, it doesn't necessarily look as nice and visual because it's not the same amount of columns, but generally in web we can let it go. But the other problem is, what about the interval time between the full pages and the last page that has now an odd number relative? So on the example, actually, we've set 20 seconds per slide on that example. And the last page obviously only has 2 items. Now, setting 20 seconds is potentially probably a bit wasteful. So the question arrives, can we calculate a different interval difference for that last page? Because we don't necessarily want to be having it for 20 seconds. So we can do that, but we need to basically provide a few variables first because we need to actually know a couple of things before we can make the calculation. So we need to know the carousel interval overall. So in this case, we've set it as 20 seconds, but it's represented in milliseconds because it's using a JavaScript plugin. We now need to know the total items before they're batched. So that's the total of items that we are going to have in any page, but we haven't set the batch size yet. So that's the total of items unbatched. So in this case, 102. Now we need to know the batch size, so that'll be the max number of items per page, and we're going to set that to 10. And then we need to find obviously the last page items total for just the last items. So obviously for the final page, which is page 11, how many items are there going to be in that? And in this case, it's 2. So we need to do a few calculations. So I'm not great with maths. My father was an accountant, and I didn't get the maths gene from him. But occasionally I have to do maths in my world, and this is a bit of a fun one. So first of all, we need to get the last page items remaining, and we can do that just by doing a total items and then do a modulus with batch size per page. That will give us 2. So we've got the amounts that we know left on page 11. Now we need to do what we call interval diff. So we need to take the batch size, so 10, and then we take the amount of pages left, which is 2, and then we divide it then by that batch size. So that gives us 0.8. Now the 0.8 is going to be critical for the next phase. So percentage of the interval, essentially the amount of time that we essentially want to calculate, or rather don't want to have as the interval anymore, that would be the last page interval result, so of the second calculation, times by the carousel interval, which is obviously 20,000. So that's essentially taking the 0.8 and timesing it by the current carousel interval, which is 20,000, and then that will give us 16,000 as a number. So bearing in mind we're dealing with milliseconds there, so that's 16,000 milliseconds, 16 seconds. But we need to do a final calculation, which is then to calculate the actual last page interval that we want. So that's taking the original carousel interval, so the 20,000 milliseconds or 20 seconds. We take away the percentage calculation of the interval, and then we also add in a bit more extra milliseconds just to pad it out a bit. So it would return 4,000, so 4 seconds. However, we may want to pad that just a little bit more to give us a bit more time for that. However, that's now give us a calculation for when the last page is not the same amount of items as the batch size. So it kind of brings up an important point. The display time is precious. So while we've done a lot of maths there, we've actually saved 14 seconds by not showing the last page for the same amount of time as the full batched pages, because there's just less information on there. So that's really useful, because while obviously 14 seconds may not seem that much, it does mean that it will have a massive impact on that paginated layout. Will be able to loop around quicker, so more full pages going to be displayed, and depending on obviously the total layout duration that's been set, there'll be more time to cycle through on repeat as well, so it'll be more time to loop through, and there's obviously that means more chance of viewing the content, which is great. And then sort of bringing up another point is dynamic batch sizes. So all of the examples so far has been dealing with a fixed batch size, say 10. What about different batch sizes for different screen ratios? So for 1920 by 1080 landscape, the batch size is 10. So that gives us a 2 by 5 grid, so 5 items per row. But what if we turn that onto a vertical? Well, it turns out that despite obviously the width being much more constrained, the height actually allows us to fit 12 items quite comfortably. So that shows that not only is it important to obviously design with sort of, responsive design in mind, but also the batch size being customizable based on what screen it's being displayed on, particularly obviously the aspect ratio. So for vertical, for example, we can fit 2 extra events per page. So actually we've gone from 11 pages on the landscape to 9 pages on the vertical. So that technically means that the vertical can display more information than the landscape. So you could actually see more of that information in less time. So interesting to note that dynamic batch size is something to consider. So again, so from that example, you can see that we can actually display 12 items versus 10, and you can definitely benefit from adapting sort of layouts, not only from the sort of amount of rows or whatever, or the amount of columns per row, but also the batch sizing as well, having a important impact. We obviously use web layouts quite a lot, as you can see, and it really does start to pay off because these kind of things are really adaptable. For example, batch sizing, we can simply just send a URL parameter to the layout, and it will automatically adjust based on the number that we've put in the query parameter. So we have the same layout, so the links there are going to the same layout, so it's not duplicated, it's exactly the same layout. There's just a bit of logic in the template that when it sees the batch size URL parameter, it will adjust based on the value provided. So we can set it lower, we can set it higher. Technically, we can set it beyond its capabilities in terms of the viewport, but obviously no one's necessarily doing that because it's all sort of set by layouts, and the target, or rather the HTML resource being pointed at, will always be set to something that's logical and been tested. So that's fine, but it does show the dynamic nature of obviously being able to adjust the amount of items being displayed as well. So I just wanted to kind of finish up with the final bit of, we've talked about obviously digital signage being non-interactive, but there certainly is digital signage out there that is interactive. And we've actually just, we're about to go live with some portrait e-posters, which are touch enabled. So this kind of made me think about sort of all of our existing signage using like the carousel sort of pattern. And we can actually basically add in the touch support that's technically there already, but we don't want the controls visible obviously on our non-interactive signage because there's no point. But what we've been able to do is essentially, again, it's not a layout duplicated. We've essentially able to use the same concept of when we pass a certain URL parameter in, it will enable the touch sort of features of the carousel. So we can see that we've got the sort of controls here. So on the left and right here, the buttons. They're pulsing to kind of like bring attention to them, and you can see there's a mouse click at the moment doing that, but in reality that could be a user swiping or tapping on the controls. So it really does allow control of the actual signage layout by the user. And there's further developments we can do there. So at the moment, a lot of it is based on autoplay because the majority of signage that we have is non-interactive. But further developments, we could obviously add in specific touch controls. We could even have a complete pause button. So we could allow basically full control to the user by being able to just pause it or manually control it through gestures as well. So essentially disabling the autoplay functionality when it knows someone's been interacting with it. So it then doesn't keep moving around and probably getting a bit annoying if someone wanted to actually scroll through. So those are just some ideas that we were kind of thinking about as we bring on interactive signage. And that's kind of it, really. I thought it was an interesting sort of concept that we've kind of been working with. I'm sort of the main developer at the college. Digital signage has kind of become a side project, but a fun one because it's still web, but in a different way. So it's kind of using web principles, but then also steering away from some of them, which is interesting because it kind of goes against some of your training and core principles when you're doing sort of true website development. But signage and web is something that I think is really powerful, and we've kind of leveraged it a lot, I feel, and I feel we're kind of just using it more and more to kind of make our digital signage layouts stand out. So but yeah, I hope that was useful, and if anyone has got any questions or they want to chat further about it, my email is on there, my LinkedIn's on there. I don't tend to use LinkedIn, to be fair, and my GitHub's on there if anyone wants to know what projects I've worked on in my spare time. But yeah, thanks for watching.